today we are going to present about our final year project, which is producing biodegradable plastic food wrap, presented by me, Nazati Syafiqah binti Muhammad Samri Kamel, along with my two friends, Nurul Anis Rabla binti Muhammad Yusri, and also Syed Taufik Akmal bin Syed Nasiruddin. So, let's get started! Food packaging is an important part of the food industry and helps to store food and drinks in a hygienic manner. Some packaging products, such as plastic, contain polyethylene that can release toxins and may be hazardous not only to consumers but also environment. This project aims to develop the biodegradable plastic food wrap that were made of natural ingredients and also to reduce the plastic waste. The main material that were used in this project to produce the bioplastic food wrapper is Carrageenan. Carrageenan is the generic name of natural, water-soluble and sulfated polysaccharide. Carrageenans have exceptional physical properties like thickening, chilling, stabilizing ability and also binding ability that make it the most suitable material to produce bioplastic food wrapper. This biopolymer will be mixed with starch as it contains amylose and amylopectin to provide a synergistic effect to their physical chemical properties and can reduce its sensitivity to humidity along to increase the mechanical properties within a certain range of mixing ratios. The presence of sorbitol and glycerin in the bioplastic has the same properties that can increase the tensile strength, elongation, and elastic modulus of the bioplastic. Plastic wrap is most often formed from polyethylene LDPE film, which causes serious consequences to the marine life and also to the societies along the coastlines. Approximately 4.8 to 12.7 million tons of plastic waste are entering the ocean yearly, and under the current trends, the plastic waste will increase 4 times from 2010 to 2050, meaning that by weight the ocean could contain more plastic than fish. Despite the government's revelation on the shocking figure of the waste generated each year, the recycling rate of post-consumption plastic packaging among Malaysians are still relatively low. In 2019, a study commissioned by WWF, Malaysia has the highest annual per capita plastic use at 16.78 kg per person compared to China, Indonesia, Philippines, Vietnam and Thailand. In terms of plastic waste, Malaysia ranked the second highest in overall generated waste. Firstly, reduce plastic pollution as they can degrade when exposed to the sun's ultraviolet radiation, enzyme, bacteria, water or wind abrasion. Secondly, easy to recycle. This type of plastic not only takes less time to decompose, but can be also easily recycled through an organic process. There have no toxins or chemicals. Lastly, consume less energy compared to conventional plastic. Manufacturing of bioplastic do not require the process of assessing, finding and transportation of hydrocarbons. This means fewer fuel fossil will be used, hence reduce the environmental pollution.
The aim of this study is to assess the effect of using different plasticizers such as sorbitol and glycerin on the biodegradation property of Carrageenan bioplastic film. The method used is the Carrageenan bioplastic is made by blending the plasticizer and transforming a film of the respective content. The result shows that glycerin Carrageenan bioplastic has active biodegradation activity and are more water soluble in contrast to sorbitol Carrageenan bioplastic.
The disadvantage of using conventional plastic wrap. Plastic contributes to a global plastic contamination problem. It's difficult to recycle and is made from potentially harmful chemicals, particularly as it breaks down in the atmosphere. Some include vapors within the design to protect the metal and electrical parts from corrosion while being stored. Some types of plastic wrap come from recycled plastic resins designed to break down over time in landfills. Plastic wrap is difficult to recycle without advanced equipment, machines are clogged. And even though plastic wrap is recycled, it's more costly and than using the new materials. When it ends in landfills or incinerator, both PVC and PVDC will release a highly toxic chemical called dioxin, says the World Health Organization. In marine ecosystem, plastic wrap leads to a major problem of plastic waste, but unlike other plastics, scientists find that PVC and PVDC do a lot of work in capturing bacteria and metals. Those infected pieces of microplastics then damage the fish that miscarries them for food. Besides that, plastic takes over 1,000 years to decay.
In Malaysia, there are a few companies that are engaged in producing bioplastic products from seaweed. Rodomat Sdn Bhd is one of the companies located in Tower Sabah that trigger the ability of seaweed as the replacement for conventional plastic. Their product is seaweed-based bioplastic packaging that are heat-sealable products which can be colored and printed on. But this company did not yet produce bioplastic wrap. The new bio-based polymer has been developed for making biodegradable packaging as an effort to extend the food quality, shelf life of food, and to reduce the waste from plastic itself. Compared to conventional packaging, the key benefits of bioplastic are the use of renewable energy, biodegradability capacity, and edibility. Seaweed provides some significant benefits including its low cost and abundance in nature, relative to terrestrial plant sources. In addition, as non-terrestrial plant material, it is needless to clear productive land for planting crops or interfere with food production. Besides, seaweed is intended to reduce the effect on food chain and is normally protected from exposure to chemicals or fertilizers.
Material used in this experiment is carrageenan powder, cornstarch, sorbitol, glycerin, water, and food coloring. Equipment used in this experiment is non-stick pan, stove, spatula, glass pot, and hand blender.
Next is the procedure in preparing biodegradable plastic wrap from seaweed. Firstly, pour 200 ml of water in a pan. Then, add carrageenan powder, cornstarch, glycerin, and 3 drops of food coloring into the solution. Next, add the solution over medium heat, and stir the solution. Make sure the solution is stirred continuously until all dissolve. Then, turn off the heat and remove it from the burner and blend it again using hand blender if there is a lump. Pour the mixture into a non-stick pan and spread it into a thin layer with a thickness of 3 mm. Then, dry it in the oven for 75 degrees Celsius for 1 to 2 hours until it dries. Lastly, repeat the steps by using sorbitol and different food coloring. So, there are two characterization tests that we carry out on our bioplastic film. The first test is the biodegradability test. The second test is the water solubility test. For the biodegradability test, the plastic stapler with the cardboard will measure 5 x 5 and make a grid. Next, bury the plastic in the soil for a week. After a week, the plastic is tested by looking at the changes. Then, record the observation on the plastic. Finally, this test is performed simultaneously with the plastic made from sorbitol. For the water solubility test, pour 100 ml of water in a container. Then, immerse the plastic in the water and stir slowly. After that, observe and record whether the plastic dissolves or not.
Hello! It's been a while since the last time I wear my lab coat. Perhaps today is the last time I wear this lab coat for the rest of my diploma life. My name is Kamal and I will be presenting on result and discussion. Now, before we start, I would like to make a clarification on the limitation of the experiment. No laboratory equipment are used to characterize the actual biodegradation property of the Carrageenan bioplastic film in a quantitative sense. Therefore, our observation is limited to qualitative physical observation. However, the color change, the texture loss, and the changes in appearance should provide sufficient evidence on the bioplastic biodegradable property at the lowest basic level. Now, let us begin. In brief, all Carrageenan bioplastic films show texture loss and changes in appearance after 7 days being buried into a soil. As we can see in the pictures, all Carrageenan biofilm colors become darker and show loss of texture and appearance as the day progresses. Now, texture loss meaning here is they become softer and some are loss of robust appearance, aka does not seem strong. Of course, if we want to quantitatively test the tensile strength of the bioplastic, we need a tension test machine, but we can because of MCO. We continue. A detail of observation on the sorbitol Carrageenan bioplastic film seems to show that it has antimicrobial property, or is it not? This is because on day 5, sorbitol film does not show microbial growth on the surface of their structure as compared to control and glycerin film. There's no study were found to prove that sorbitol have antimicrobial property. However, based on this paper, which I cannot have access on, it is suggested that this inhibition of bacterial growth is the result of the osmotic effect and the chemical structure. But still, on day 7, all of the films show microbial growth. Moving on to the water solubility test. Based on the result, glycerin shows faster solubility time. It's dissolved in the day 5 as compared to control and sorbitol film, it dissolved in day 7. From this, we can say that glycerin is more water soluble than the sorbitol. Now, there is a contradiction of what we expect initially. Let's take a look at the glycerin and sorbitol molecular structure. Here is the glycerin, and here is the sorbitol molecular structure. These plasticizers differ by their hydroxyl group. Glycerin has 3 hydroxyl groups and having 92 grams per mole of molecular weight, while sorbitol has 6 hydroxyl group with weight of 182 grams per mole. We assume that having more hydroxyl group will result in more water will interact with the hydroxyl group, resulting to higher water solubility as can be seen as the sorbitol, but the results show otherwise. Glycerin seems to have higher water solubility as compared to sorbitol. Now, why is that? According to an article in 2017 of the similar study on the Carrageenan films, titled Effects of Plasticizer on the Psychochemical Properties of kappa Carrageenan films extracted from Euphemia cottoni, it says here that in terms of plasticizer type, glycerol plasticizer films have the highest moisture content, followed by PEC 300 and sorbitol plasticizer films. The hydrophilicity of the plasticizer greatly influences the moisture content, where a higher number of hydroxyl group contained in the plasticizer will increase the moisture content. However, although sorbitol possesses 6 hydroxyl group, the moisture content of the sorbitol plasticizer films was the lowest compared to the other films, even though glycerol and PEC 300 contain only 3 and 2 hydroxyl group respectively in figure 2. This was probably due to the lower hygroscopicity of the sorbitol, which means that it has less ability to absorb or release water. Hence, sorbitol tend to maintain the moisture content of films even at high concentration. Now, it shows here that our assumption is not entirely correct. Possibly the hydroxyl of the sorbitol tend to have stronger interaction with the Carrageenan polymer, therefore resulting to lower capacity to react with the water. While on the other hand, glycerin seems to have higher water equilibrium content as compared to sorbitol, resulting in higher water solubility and greater biodegradability capacity. In summary for the discussion, higher microbial activity and shorter solubility duration will result in more active biodegradation property, as we can see in glycerin Carrageenan bioplastic film. Adding sorbitol plasticizer tend to increase the biodegradation time and longer water solubility duration, and higher hydroxyl group content does not correspond to the higher water solubility. Now, perhaps the commercialization of the film is not limited to the packaging industry only. In the pharmaceutical field, we can somehow use the Carrageenan bioplastic film as a way to improve the extended release tablet. Based on our result, if we are able to manipulate the sorbitol and glycerin concentration within a single film, we can somehow make a better extended release tablet. Therefore, we can improve the drug delivery system in the field of pharmaceutics.
So, as a conclusion, the result of the study is that Carrageenan is the most suitable material to produce bioplastic wrapper as it degrades faster compared to conventional plastic. The degradation test and the solubility test, glycerin Carrageenan bioplastic film shows the highest biodegradable activity within a limited experimental time of 7 days and showed excellent water solubility as compared to sorbitol Carrageenan bioplastic film. Thus, the usage of the bioplastic wrap. It has high potential to replace conventional plastic wrap and also help in reducing plastic waste. But there is the limitation in the study, where the limitation of the experiment is only constrained within qualitative analysis, which will all the results are taken from the physical observation of lost texture and changes in the appearance of the bioplastic film when buried in the soil or immersed in water for 7 days.